Hello, welcome to the NATS tutorial about building secure and decentralized global applications running on Kubernetes using NATS. My name is Waldemar Quevedo, one of the core maintainers from NATS. You can find me on Twitter as WaldQS. I'm a software engineer in Synadia, where many of the maintainers of NATS are working. I've been a long time NATS user. I wrote a book about NATS a couple of years ago, covering many of the basic concepts, some of the messaging patterns that you can do with NATS. And in this talk, this tutorial, we're gonna cover how to set up a decentralized authorization scheme for a NATS cluster. Then we'll deploy a NATS supercluster of 3 regions using Helm. And I'll show the internals of a chat demo application that is using those credentials and dynamic provision of credentials and a global NATS supercluster. This is how the NATS application, chat application looks like. You can have a number of channels, and then users can send messages to anyone that is member of that channel. And they also have support for direct messages. And in case one of those messages, whenever you receive a message, you get a dot, basically telling you that you have a new message. In terms of NATS streams or subscriptions, this is how they look like in terms of the subjects that are going to be used. We'll have a subject named chat.kubecon.posts, and using the wildcard, the asterisk wildcard, so that whenever you post to KubeCon, that's going to be represented by a message that it is on the subject.post.kubecon, or for the NATS channel and .NATS on general, the same. Then the DMs, how they will be implemented is quite interesting. But as a user, as a client user, will be able to receive messages from anyone that is part of the cluster, part of the that is connected to the cluster. And also you eventually be sending regular events, status events, to announce to everyone that is connected to the chat service that you're online. And also in terms of the services, because NATS has support for not only a sequence of events and streams, you can also use services. So basically make RPC requests on to get a single response. So in this case, a service that will be part of this is the request for access service. So there's going to be a single subscriber, part of this NATS cluster, that whenever you make a request with some payload, in this case, the payload is going to be the username. You can make a request to chat.rec.access to get some ephemeral unique credentials for that user, and those are going to be generated on demand for each one of the users. In terms of the global topology, this is how it's going to look. We'll set up a NATS cluster in San Francisco, Amsterdam, attending virtually, and also another one in Singapore. There's going to be a credential service that could be connected anywhere. It's going to be a queue subscription so that you can have multiple of them, and they will become a load balanced. And then the chat client application can be connected to anywhere from this part of the cluster. So there's again, it's decentralized. There is no center. All of these could be running everywhere. So I'm gonna get started. And so the first thing we need to do is set up the auth for the cluster. So we are going to first install NSC. In case it's not available, NSC is the tool that you can use to manage users in NATS, users and accounts in NATS. There is a one-liner that will install it for you. You can peek at the contents in case you're concerned of the whether schemes you want to pick at the contents basically, or you can just use Homebrew to install it. So we'll need NSC, and there is we'll use this script NSC setup that is part of the Kubernetes repo, and also all of this is going to be available on another repo for the KubeCon 2020. So you can see all of the code and examples here as well. So let's first, let's get started and bootstrap the authorization. Okay, so let's go into the KubeCon 2020 folder and make run this script that is going to create some accounts for us. One of them is that is going to create the operator JWT that is going to be used like the root of trust from the whole cluster. And we also create a system account and a couple of accounts for testing, and one for Stan, for example, in case it could be used. We're not going to use it particularly in this tutorial, but it's just like a generic account. And the operator JWT is quite important. As I mentioned, is the root of trust from the whole cluster. You can see that it is set to, it was issued, it doesn't expire, but you can, if you take a look at the script, you can also check how when you want to make it expire, and so all of that can be configured. So for the purposes of this demo, we're gonna need at least 3 different users. One is gonna be the user for requesting credentials, and there is gonna be a user that has very constrained permissions. Then we will need a credentials provisioner that is able to respond to those requests. So those are the service interactions. And also we'll need user credentials for each one of the users. These are going to be dynamically generated, and I'm gonna show how this is done. So, but first, let's create a KubeCon account. Let's create a KubeCon account. So all of these users are gonna be part of this KubeCon account. And we'll do something special with this account, that is we're gonna create a signing key. This signing key is it is an extra key that is gonna belong to this KubeCon account, and it is essentially what we'll be using to create the new users that are part of this cluster by using the dynamic credentials provisioner. So let's edit the account using this signing key. The signing key is the one that is in the output. The second one here in the output. AA means that is a public key. S means that is a private key. So this is the one that we want to use. So now let's edit the account for KubeCon and add another signing key. So let's inspect. You can see that I have a signing key now. Next, we want to create the credentials for the provisioner. We still need to continue to use the signing key. So I'm going to replace this here with the one that got generated. And it is limited in terms of the messages that it can respond. So it can only subscribe to requests for credentials. In this case, it's going to be a chat.rec.access. and it is going to be able to respond to requests. So that's why we need this inbox. So at the core level, everything Nats is still publish, subscribe. And so in order to be able to reply to requests, we need to be able, and make requests, we also need to make a subscription to inbox. And because there's going to be a super cluster that is going to be multi-region, we also need an extra level of permissions, which is at the _R for routed globally, requests that are routed globally. So we'll need these permissions, and let's go ahead and create the user. So you have a new user. Now let's create the user for asking for credentials. This, similar to the request, the provisioner also have very limited permissions. You can only request for credentials and you cannot do anything else. So the only type of message you can send is for getting more credentials. So it's going to be a harmless user. So now we have these couple of users created. And let's just confirm. Yeah, so we can only publish to chat.rec access and send messages to inbox. Receive messages from receive responses. With this, we're ready to start confirming the setup locally and show some of the code as well. I'm gonna make this a little bit bigger. So now we are going to start the NAT server. But for this, before we to do so, we need to create the configuration for NATs that includes all this information about the accounts. So NSC can help generating this. In this case, we're going to use a static memory resolver that gives contains the JWTs from each one of the accounts. So the NAT service do not have any notion about the users that are part of the system, but does need something that at least notion of which are the accounts that are indeed part of the cluster, so that they were signed and all their signing keys and stuff. So in this case, we generate the config. We include the operator JW key here. I name it KO. And we also have this system account that accounts show that is for able to inspect system events that are flying by in the cluster. So we use this configuration. And let's start NAT server. Conf resolver. So we see that we have a new a KO operator with the latest NATs that is available for requests on the port 4222, which is the port for client connections. We'll make a simple mock request using the credentials that we created. I'm gonna start a screen session. So we're gonna try to make a request to NATs. There's no access, okay. Try to make a request for NATs, but there are no responders to able to provision these requests, provision credentials, or response basically, because right now there's no logic still. We're just creating a mock service that is gonna be able to respond to this request. So now we have a mock responder, make another request, and we can see that there's a request response interaction with these two. If I try to make another request here, I'm gonna get deny. The same if I try to subscribe to another subject is not possible. So those are the only things you can do with these credentials. The one for the making requests and the one for provisioning, or basically just responding to anything that is, any message that is sent to this subject. Okay, so using those credentials, and let's try to create a provisioner. This just crashed. So Emacs just crashed, and but anyway, repos, next step, GitHub. Okay, so we have the tutorial. So this is where we were, and we want to start the provisioner. And we need to pass it the signing key, as it was mentioned before. The code is inside of this, the chat access within the repo. So let's go ahead and start it. We have now something that can provision requests, and let's try to make a request to get some credentials. I'm gonna make a request, fetch credentials for WallyQS. We can see that whenever we make a request and I pass in the payload, in this case, which is going to be the username, I'm going to get these dynamically generated requests credentials. Well, yeah, they're always going to be the same. If I pipe this into, let's say, my credentials, then I'm going to inspect them with NSC. You can see that these the provisioner created a very also a limited permissions for this user. So the name is a user, but it's better identified by the public key. And that's why we needed the signing key to be able to generate these users using that key pair. So we have this WallyQS user that is part of the KubeCon account that is only able to send messages to publish that is online on a chat to any other messages. And this is a very interesting that you're constrained to only be able to read your own DMs messages. So you can publish to any DM, but you can only subscribe to messages that will, as represented by the public end key from this user. So we can use these credentials to start a session in the chat, in the chat folder. Let's create a session. Great. So we can now send messages. And let's create another user. Let's say attendee. Credentials and chat. Secrets. Where are we? Okay. Threads. Type chat. You have a couple of users. Welcome to KubeCon 2020. Start this server and move it to trace to show some of the messages. So everything should just reconnect to the server. You can see that most of the traffic that is flying by is just JWTs being exchanged. It is just in the JWT library from you can find in Nats.io. So yeah, we can send messages to the general channel. Also, for example, you can send private messages. You can see that there's a dot now that it received the message. You can read it. Okay, so how does this work? Let's go take a look at the code. First, let's check the provisioner, how it's provisioning the requests. This is, again, a service. And this means that service, it is something that you usually expect for it to be load balanced. So we're going to be using a queue subscription. In this case, it's receiving a request on the chat.rec access, as we have said previously. So it is receiving request on chat.rec access, and it's going to generate requests on the fly for the user on a number of subjects. The one for heartbeats, for the general channels and DMs. And it's going to use the signing key that we passed to the provisioner to be able to create the users, and also take advantage of that identity to be able to create unique channels for the DMs. And this is, in terms of the code, how it's creating the JWT, the credentials. So it is creating them. Create the JWT, encoding into a byte payload into bytes, and then just generating these credentials that are very similar to the credentials that we have used, created with NSE before. So this is a very simple provider, just a queue subscription that represents the service, and then respond with the credentials. The NATS requester was just a simple NATS request, and so it's just calling a request in the API level. And for the chat application, it works by using those credentials, and it subscribes to a number of streams. You can have, we can see that there's a stream for the channels, and it posts up for the DMs, and for sending the events that they're online. And whenever we want to publish something, we will, of course, send periodic events for that we are still online. And also, in case we want to post to one of the channels, we'll send a request. Okay, this is fine. So we're going to publish into this certain subject. And for DMs, we need to have received a previous heartbeat so that we can talk to it. So we need because we need to use the public end key, we need to receive at least an availability status from one of the heartbeating that happens periodically. So it's pretty simple, and then it's a very nice UI wrapper using one of the libraries from Go. But in terms of nets, it's pretty straightforward what it's doing. Most of the heavy lifting is done by the authorization. Okay, so this is how it looks like running locally. Let's leave this like that. So you can just leave it there, and we can reconnect to another supercluster later. So we'll just go ahead and get started creating the supercluster on Kubernetes. This is gonna be composed of 3 regions, as I mentioned at the beginning. It's gonna be one in Singapore, Amsterdam, and San Francisco. We're gonna connect the clients similar to how we did locally, but they're gonna be now connected to these other nodes. To keep it simple in terms of the tutorial, we're just going to be using the public IPs from the nodes. We're going to create 3 different clusters using on DigitalOcean. We need the firewall to be open because we're going to be using host ports for the port 422 and especially 7522, which is the one for the gateway connections, as represented here by these blue arrows. And we also leave open the port for leafnodes, which is another type of connection that's very interesting, that allows you to create at least hub and spoke topologies. So essentially, you can use this supercluster later as a way to be able to communicate with multiple NATS clusters without them themselves becoming a cluster. But that can be another tutorial. So we leave those open, and we'll be using Helm for the setup. So you can officially support NATS Helm charts. And I'm gonna move this to right now. So it's officially support Helm charts, so you can repo, add this into your list of repos from Helm. We're gonna upload first to each one of the gateways the resolver configuration. Just to confirm that we already have provisioned the clusters. So right now, I'm using the cluster from Singapore. So I'm gonna change to, let's say Amsterdam. Okay. And we're using the external IPs to be able to create the supercluster. So let's go ahead and create first the NATS accounts. It's gonna be a configuration map in each one of the clusters. And we need to generate the list of gateway connections. So just create a script to generating them from the API server metadata. Okay, this is wrong. Mhm. Yeah, so I have generated now the list of public IPs, and we're gonna use this as part of the Helm YAML. So let's use this explicit list of gateways. Going over the configuration a little bit, we're using Alpine just for simple debugging. And we'll open a host port for each one of them. So that is done by using this external access flag. No logging, that affects performance actually. We'll enable auth. For the auth, we're gonna use the NATS accounts configuration map that includes the static configuration from the accounts. We're enable the gateway ports, and also with the explicit IPs from Amsterdam, Singapore, and San Francisco. These are explicit IPs, but you can use, for example, DNS instead on a single endpoint, and then you can resolve the A records into a number of NATS servers. So that is totally fine. Let's use this configuration now and deploy it to Kubernetes. So now we should have 9 nodes. So we see that it got deployed to Amsterdam, next San Francisco, next one's gonna be Singapore. Let me show this. Okay, and let's now confirm the setup, get pods. That's 0. You can see that we have a connectivity between the clusters. You have a local clustering working, and also it has created outbound gateway connections. In this case, from Amsterdam towards San Francisco. And let's confirm. For example, here we are at Amsterdam, so let's make a quick connection here. You can see that we can get on the cluster, and we got disconnected because we didn't put any credentials. So now let's use this to make a request from Amsterdam. I'm gonna create a service here. Similar to how we tested locally that the request response was working. We have something here working now. Let me disconnect this first. Let's create this service. Now let's use one of the IPs from San Francisco. To make a request. Okay. So all of this is being routed globally. Mm-hmm. Now we can technically use this to expose the application. Just a quick example, I'm going to show the system credentials, just to show how the traffic looks like. These are the events that are flowing through the system. For operations, they can be quite useful. You can see how many gateways and the stats from each one of the servers. They're pretty readable. And we also have extensions to be able to ingest this data into Prometheus. There's the Surveyor project. So yeah, but it's a nice way to inspect how many connections and total connections have the status from each one of the nodes and whether gateways are happening. Okay. So there's connectivity, and we can, instead of basically doing the same that we were doing before with the credentials, let's run the credential instead of to the local server. We can run it here. In this case, this is a 138, this is San Francisco. So I'm gonna say that this comes from SFO. I'm gonna create a provision here. This is, okay. Okay. Chat access should be okay now. Have an extra S. So you can see that we connected from SFO. Let's add another credentials provisioner, but that is connected from Singapore. Keep going. So we're connected from Singapore. So I have 2 connections. Make a third one that is gonna request for credentials. Let's say it's an attendee. So if you make a request to Singapore here, that is the node that is gonna read. In this case, okay, it's 38. So actually, they're connected to the same IP. Okay, so I use the same IP. This one was Singapore. The other one is San Francisco. Let's connect this one to Singapore actually. Then if I make a request from Singapore, that is the one that's gonna handle. So you can see that there's a label now, SGP. But if I send something from San Francisco, SFO attendee. That's from SFO, SF. But here's so we're making requests to SF, but if it fails, then we'll start receiving requests from Singapore. So that's thanks to the queue subscription and the routing and the disaster recovery features from Nats v2, there was automatic failover from the consumers transparently. So yeah, we basically another Kubernetes cluster is handling the request for us now. Okay, so let's make the credentials from SF attendee. SF creds. Another one for and now let's make another request for Amsterdam. Let's start the chat using, so this one is going to connect from Amsterdam. Using the credentials from Amsterdam, I connected. And this other one is going to connect from Ceph. So now we have a globally available chat service with unique identities. It's secure. You cannot read the messages from other attendees, but they can still communicate amongst them, between them. We cannot, you can take a look at some of the, you cannot, even from the system account, you cannot receive the messages. And there's no user that has enough permissions actually in this system to be able to read the DMs from anyone. There's no credentials that allow you for, allow for that to happen. And so that's pretty much it for the tutorial. Separately, we can cover how to enable all of this to use a TLS, and also looking at how leafnode connections can actually make this gateway connections more straightforward to set up. That could also be interesting. But okay, I'll connect then at for questions later. Okay, so thank you.